Okay, so today is a brand new video, and the question that I'll be solving is on another question of geometry. So what's the question today? Now let's take a look. Okay, I'm going to shift this over. Okay, so this is the question. You're given a right triangle, all right, and you're given that, all right, the radius of the inscribed circle is 2 units in radius. Given that from the radius all the way to one point of the triangle is x angle, x degrees, and the other angle over here, this is 2x. So what's the question? Now, the question is, what's the area of the triangle? Okay, so how do we find the area of a triangle? First of all, I'm going to establish, all right, that another two more radiuses, okay, radii, okay, over here. All right, and you can see that these are all in tangent, okay? They are tangent to the respective lengths of the triangle, okay? And we all know that, okay, a radius to a tangent forms an angle of 90 degrees, okay, or right angles. Now, very quickly, now we're going to just establish the points, okay, A, B, C, D, E, F, and O is the center of the circle. So next, we can straight away based on, okay, if you are going to look at this part here, how do I know if this is 2? Okay, 2 units as well. Now, the radius you are given that is 2. OB, okay, is also 2 units. Okay, because these both lengths are the radial. Okay, and they are forming at 90 degrees. So if they're all forming at 90 degrees, respectively, okay, these angles, they will also be 90 degrees. Thus, you are getting a square. Okay, so basically OBCD is a square. CD will be 2 units. Okay, now AC is very simple and straightforward. Okay, because you can look at triangle ACD. Okay, ACD is a right triangle. So based on the tangent ratio, okay, AC is 2 over tangent x or 2 cotangent x. Okay, in other words. Now, next, AF is the same distance as AB because the two tangents are meeting at the common points. Their lengths are the same. Okay, that is a theorem of circles. Okay, so how do I know that this is 2 cotangent minus 2? It's very simple because simply BC is also 2 units since OBCD is a square. So BC is 2 units and AC is 2 cotangent x. So 2 cotangent x minus 2, I get AB. Okay, so AB is also 2 cotangent x minus 2. Okay, so in other words, AF is 2 cotangent x minus 2 units. Now I'm going to draw another line, OE, joining O and E. And you will see that it forms another case of two tangents intercepting at the common point E. So thus, DE, okay, and FE, they are equal in length. And triangle FOE and triangle DOE, they are congruent. So in this case, all right, angle FEO and angle DEO, they are angle bisector. So since DEF is 2x, okay, the two angles, I can split them into x and x. So we can see this pretty easily now. Why? Because based on triangle ODE and OFE, okay, we can see that this is 2 units, this is x, and these are right angles. So thus, okay, DE is equals to FE, which is equals to 2 cotangent x. Okay, I hope you can see what's going on here. So at this point, I can see that ACE, triangle ACE, is a right triangle. And since it is a right triangle, I can apply the Pythagorean's theorem. So the Pythagorean's theorem, I can just apply it. Okay, so basically the square of the hypotenuse AE is equals to the sum of squares of the legs AC square and CE square. So we can see over here 2 cotangent x plus 2. Why is it 2 cotangent x plus 2? It's because I'm taking the length CE. So the leg CE is 2 plus 2 cotangent x. Notice, okay, CD plus DE. So over here, we have 2 cotangent x plus 2 square plus 2 cotangent x square, okay, which is our length AC, is equals to 4 cotangent x minus 2 square. Okay, how do we get that? Simply the length AE. So AE is 2 cotangent x minus 2 plus 2 cotangent x. So in this case, if you sum them up, you get 4 cotangent x minus 2. Okay, and we square it on the right-hand side. Now, we actually form an equation, and we are going to just solve for what is the value of tangent x. Okay, so now the objective is solve for tangent x. So the next step, I just expand it out. Left-hand side, I expand it out. I get 4 cotangent square x. Okay, and 8 cotangent x plus 4. Okay, I just square this, expand it out. And over here, 4 cotangent square x, okay, because I square it, which is equals to 16 cotangent square x minus 16 cotangent x plus 4. Okay, basically just I expand out what we see on the right-hand side. So very quickly, now we can see that, okay, we can just combine similar terms. Okay, we can see that 4 cotangent square x and 4 cotangent square x. I sum them up, I get 8 cotangent square x. Next, I have 8 cotangent x. 4 is 4. And you can see that all those on the right-hand side, okay, I'm basically going to subtract, okay, these entire expressions on both sides of the equation. So if I'm going to do that, I will have minus 16 cotangent square x minus 16 cotangent x plus 4 equals 0. Okay, basically I just subtract this entire chunk on both sides of the equation. So the next step, very simple. I'm going to subtract. Okay, so 8 cotangent square x minus 16 cotangent square x. I get minus 8 cotangent square x plus 24 cotangent square x. Okay, so I hope you can see what's going on, because 8 and 16, because you have a 2 subtract sign, it turns into addition sign. So 8 plus 16 is 24 cotangent x. Thus, 4 minus a 4 gets 0. Okay, so now we have the left-hand side with this expression. Quite simply, I'll just factorize it out. We have minus 8 cotangent x, okay, with cotangent x minus 3 equals 0. So thus, okay, in order, we are going to take that such that tangent x is not equal to 0. Okay, we have the alternative solution, cotangent x equals to 3. Thus, tangent of x is a third. Okay, so we have actually solved at this point, okay, as tangent of x is 1/3. So quite simply, now we have the area of triangle ACE, okay, which is the objective that we are going to do in this question. So the area of triangle ACE is half of AC of CE. Okay, so half of 2 cotangent x of 2 plus 2 cotangent x. Okay, that is the area. So quite simply, okay, if I'm going to simplify the terms, I have, okay, 2 cotangent x plus 2 cotangent square x. Okay, because this can be seen quite readily. Okay, because over here you can see that the 2, you can just cancel them out. You have cotangent x, so 2 of cotangent x, okay, and 2 of cotangent x is 2 cotangent square x. So by plunging in what we have derived earlier, that tangent of x is 1/3, we substitute 1/3 for all values of tangent x. So in this case, you have this value over here, and thus the answer, if you evaluate it, the area of triangle ACE is equals to 24 units squared. And that is the answer for this problem. Okay, so thank you for watching and hope you have a nice day. All right, goodbye.